We are now going to transition to our next talk, which is Mike Del Balso of Tecton, co-founder and CEO of Tecton, speaking on feature stores solving the ML data problem.
Hi, everyone. I'm Mike Del Balso, and today we're going to talk about how feature stores are helping teams put machine learning into production with operational ML. Companies have more data than ever before, and over the past few decades, companies have been working on improving their ability to collect it, make sense of it, and extract value from it. The industry has been through a revolution in analytics, and there are tons of companies, jobs, large budgets dedicated to making sense of all this data that we've been collecting. And operational ML is about bringing analytic decisions to production, infusing smart decisions in our production applications, and enabling new classes of applications. Operational ML is about making smart decisions as reliable and simple as the rest of software, and making it easy for all developers to put machine learning into their applications. And it's something that we're really excited about. So let's take a closer look at what differentiates analytic ML from operational ML. So analytic ML is used in development and analytic environments. It typically focuses on batch analytics. You plug into a data lake or a warehouse. And typically, you're generating, one-off dashboards or one-off forecasts, something like that. Things for human consumption. And there's an increasing demand and a lot of value in using machine learning to power end user experiences and automated business decisions. And so operational ML is about bringing all of that analytics stack into the real time to support operational systems. So in the operational environment, we're not just limited to batch data, but we have a variety of new sets of data as well. Real-time data streams. We have data that the user just input, session data. And all of this data can be used to make better predictions, more personalized experiences, and generally have our machine learning models be more accurate. And there's a ton of use cases for this. So, in financial services, there's a ton of real-time fraud applications, trading applications, obviously. Retail, we're generating new personalized product recommendations and adjusting them and pricing in real time. And even in insurance, there's a lot of real-time adjustment of insurance quotes and live underwriting and price generation. And these use cases have been around forever, but it's now becoming possible for companies of all sizes to build customized operational ML systems to power their products. And we're going to talk about that today. So operational machine learning is still pretty hard to do. Teams are struggling. It's really hard to build machine learning and get it into production. And it's just not as easy as building simple analytic applications. I've spoken to hundreds of teams, and the same problems come up again and again in these teams. Data silos, duplication of effort, things just not getting to production, the production models being stuck at version 1 or version 2, and the development models or staging models are many versions ahead. And these challenges are common across a lot of organizations. So what's going on here? Well, operational machine learning is really hard. This diagram shows machine learning code, getting the machine learning code right is just one part of everything that needs to be done to build a reliable and coherent machine learning based application. There's a ton of adjacent problems that are not machine learning algorithm specific. And different companies have solved these problems. So, I was the product lead at Michelangelo for machine learning at Uber, and we created the Michelangelo platform there to solve these problems. At the time, Uber was struggling with these same issues, and machine learning just wasn't getting into production. We barely had a handful of machine learning models being used in the application in production. And the Michelangelo platform was really designed to enable data scientists to go end to end, to come to this platform with a business problem turn it into a machine learning solution, train a model, deploy that model, monitor it in production. And it really enabled Uber to scale to tens of thousands of models that are in production today in just a few years. And so some of the obvious use cases are fraud prediction, ETA prediction, pricing, a ton of different examples. One thing we discovered when building Michelangelo was that data and features were at the core of the complexity of building these end-to-end machine learning applications. There's all these data problems around that core machine learning problem. And we found ourselves, as we were helping teams again and again, we found ourselves spending the vast majority of our time solving data issues. And our central platform team was spending its time solving these data engineering challenges again and again. As we were doing this, we built out different layers of the stack and essentially a platform to automate a lot of these data engineering challenges. And that was really what the feature store was. And so the feature store is the solution for a lot of these core data challenges in being able to build and develop and deploy operational ML systems. And so we've been building applications for years. We've refined our software development process to with these DevOps processes, which allow us to quickly and iteratively build and deploy application code. And we've seen a lot of tools emerge there to make that very helpful. We're also seeing similar sets of tools arise in managing models for machine learning. So all of the ML ops platforms are really great at focusing on and managing model training jobs, model management, and the deployment of these models to production, serving models in production. What we don't really have very much of is anything to help us do the same thing for features. How do we have tools to help us do exploratory data analysis and author transformations of this data, but really to manage the end-to-end life cycle of these features, to catalog them and organize them in the development process, and seamlessly shift them into the production environment and manage that life cycle and monitor them. There's not really any tools for that, and that's really what the feature store does. Feature stores are basically the interface between data infrastructure and the model infrastructure. They allow data science and engineering teams to build a catalog of productionized data pipelines that are ready for use in machine learning applications. These are pipelines that are already vetted, and they're made available for use in model training processes or in the operational environment for model serving. And the feature store can connect to existing feature data that lives, say, in your data warehouse or other databases, other data storage layers, or it can connect to raw data in those systems and transform that data, derive features from that data. Data scientists interact with these systems by building features, deploying quickly to production, so productionizing their features, and making their features, sharing their features, making them reusable for others to use in the organization. So what does a feature store do? The feature store connects to your raw data, optionally transforms that data into feature values. It stores it in both an online and offline storage layer, which map to both the operational or production environment and the analytic environment for model training, and serves that feature data for use for real-time predictions or for model training and generating training data sets. The feature stores also monitor the feature data and to ensure that the feature values are always correct and looking for drift, but also maintain this central catalog, this registry that can be used for compliance purposes, for discoverability and sharing. So let's take a closer look at how a data scientist might use a feature store. So typically a data scientist would have one phase of defining features. And they're also using those features in the model building process when they're iteratively training models and evaluating the quality and the usefulness of a feature or a new modeling approach. And then using those features in that model in production when they're making predictions. So let's look at those really quickly. defining features. This can be declarative. This is some example code from the Tecton feature store, which shows how someone can, a data scientist might define a quick like SQL snippet, maybe some PySpark, maybe Python, to define the transformation that they want to apply on that raw data and turn them into feature data that will be continuously generated and be kept up to date within the feature store. Secondly, using these features, quickly retrieving these features in the development environment, say in a Jupyter notebook, from an SDK to join multiple different groups of features into a single coherent feature set. And so here we can see we're retrieving features for all of these historic ad impressions, and we're trying to get the group of CTR model features. And then that gives us a training data set that we just fit into, we pass into the model training algorithm. And finally, we need to use these features to help our models make predictions at prediction time. So when a user is loading a page and we need to determine which ads to show them, we want to get all the information about those ads, and that comes from the feature store. So what's shown here in this code snippet is loading a feature vector that is about this specific ad, and passing that into the model to make that prediction. And so this feature vector is loaded in real time, and it comes from potentially real-time sources. It comes from pre-computed batch features, maybe some stream aggregations that are related to how many times this feature has been clicked in the past day, or maybe even the past 10 minutes. And so that creates that full feature vector that is passed into the model for predictions. So how does the feature store help me out? Well, the feature store allows you to have better data to be passed into your models in production. So it allows you to build better models on better data. It also makes it a lot faster to deploy your models in production, because it handles a lot of the data engineering challenges that are often overlooked and are steps that really slow down the model deployment process. For example, I want to upgrade my model and add a couple of new features. Well, building all of those data pipelines for these new features to be continuously computed and served in production is handled by the feature store rather than handing it off to another engineering team. And finally, it brings DevOps-like practices to the feature development. And it does the full lifecycle management of features to make it really easy for auditability, compliance, governance, sharing of features, and making reuse as easy as possible for these features, for the next use case to not have to start from zero. But the next model you're building within the organization, they can reuse as many features, all the features that have already been created in the company quite easily. So a common problem that many teams face is that they have the data that's useful for a specific prediction, or for that is relevant to a model, be spread across a ton of different data sources. And in practice, only a subset of those data sources are actually used in production in the model that is making live predictions. And so a lot of value can be had. The model could be a lot more accurate if it was using all of the different signals, maybe like a user history database, or maybe features data that can come from transaction history, which are spread into data sources that are not really accessible in the production environment. And so the accuracy of these models is being held back in production. Why is this? Why are teams not using the features and the data that is all of the data that's relevant to the model? It's often just comes down to resources. It's just more work to connect to more of the underlying data systems in the business. Sometimes it's too much work, or the skills are not there. Regardless, it's very common for only a small subset of the important signals to be used in these models. When we are able to use all of the different data sets that are relevant to a given use case in a prediction, then our models can become a lot more accurate. And a feature store connects the model to all of those data sources that are relevant in a very easy way for data scientists to be able to use and build these systems. And so in this example, there's a prediction request coming into a prediction service, this ML model. It needs to have the data for it to make a prediction on, so it requests features from the feature service. The feature service is connected to the different data sources, not just a batch table in a database, but also a real-time system, also the streams for example, web events or the user's current session, and can provide a coherent full feature vector back to that model so it can make a prediction on fresh data and comprehensive data. All the data was missing before. Another really important problem, which kind of is some of the cause of that previous issue, is that it's just really hard to get these new features into production. So what's very common and can lead to it taking months to get the features to production is that data scientists will engineer features for model training, and then they'll basically place a request to the data engineering teams to build the production pipelines to get to deploy these features. And the data engineering teams will be their partners, but may not share the same priorities or incentives within an organization. And it can typically take many touch points between teams, a lot of back and forth between these different personas, and there's a lot of stakeholders within a team, such that these features can be built, deployed, and be present in production and validated and ensured that they're operating correctly. This process can slow down these projects by months and sometimes more than a year just to get a couple of features deployed. With the feature store, data scientists can deploy these features to production on their own. So in these cases, it increases the autonomy and the ownership of data scientists because they don't need to work with a gatekeeper who could be a data engineer or a production engineer to help them get their work into the production environment. Data scientists have now the autonomy to and the tools to be able to self-serve deploy things to production and iterate quickly with the production and with the model that's in production and the features that are in production to be able to update the systems, the models that are serving end user facing predictions. This increases the autonomy and ownership of the data science team, and really unblocks them by not requiring them to have a complex interaction between multiple personas and a lot of different stakeholders in the process. Finally, a really common problem that anti-pattern really that different teams have is that they will have a lot of replication of features. Teams will rebuild features again and again. And this can be because someone didn't know that a feature was already implemented. It could be because a feature is implemented in production in a way that their production model is not able to access. It could be because there's just not trust between these different people, and the contract between these features and this data is just not there. So, if you've built a feature, I might not trust that my model, I want to depend my model on that. It's a data dependency for my model that for which there's not a clear contract. I don't know if this data set goes down, if you're going to be on call and you're going to be the one to own that outage, or if I'm going to have to do that. So sometimes it's just easier to rebuild things on your own. And so this leads to a broad spread of duplication and data silos across an organization. And feature stores are some of the highest value data we have in the organization, but they're not really treated as data assets, and we're not really managing them that well. And this leads to a lot of problems. So the feature store provides standardization and centralized management. So the feature stores contain this kind of standard definition of all of these features, manage them in a central Git repo. Data scientists can discover existing features and reuse them across models. And really, they bring a DevOps-like sense of iteration and management of features as software assets. So an example company that has gotten a lot of value out of using feature stores is Atlassian. They began using operational ML to improve a lot of customer experiences in some of their products like Jira and Confluence. And before using a feature store, they were facing a lot of data engineering challenges, and they had teams building custom pipelines that were brittle and took a lot of resources to create and maintain. It took months to get a new model into production. And production pipelines were built with teams of multiple data engineers. And there's inconsistency between the data being used at training time and the data being used in production time. And so Atlassian implemented Feature Store as a core component of its infrastructure stack for operational ML. And with their Feature Store, Atlassian reduced the time it requires to get a model into production from months to a few days. It eliminated a lot of dependencies on existing data engineering teams. It achieved more accurate features and therefore more accurate models. And a lot of the models increased in accuracy by a significant margin. So how to get started with feature stores? From my experience building Uber Michelangelo, I knew firsthand the importance of feature stores. And unfortunately, a couple of years ago when we were building Michelangelo, there weren't any real open source or even like commercial options. So we had to build everything on our own, very specialized to that company's infrastructure. Today, Tecton backs two different options to help organizations get started with feature stores. Feast is the dominant open source feature store. It's self-managed. It supports batch and streaming data, and it can plug directly into your external feature pipelines. Tecton is a fully hosted, fully managed cloud service, and it's basically feature store as a service. And it includes support for batch streaming real-time data and automates a lot of feature transforms. So you can check that out at tecton.ai. We also have a booth that you can check out here, and we're looking forward to seeing you there. Thank you.
All righty. Thanks so much, Mike, for that great presentation. We've got a bunch of questions already. Let's get started off with a topic that was pretty popular in the chat around the feature monitoring features of a feature store.
Yeah, so one of the great things about where the feature store sits in the machine learning stack is that it really is at the center of all the data flows for of all of the parts of your stack that are touching your data, right? So, the model training system gets a training data set from the feature store. The prediction service is requesting feature vectors to make a prediction. And that means that all of the ML data flows through the feature store. And so it's a very natural place. One of Tecton's customers said to us, you guys are like on the line, like you're plugged into the data, the core data line there. So it's a natural place for monitoring to plug in. And so at Tecton, we in our feature store, we've built in nice interfaces to make it possible to plug in basically any monitoring system into that data. So that allows there's a couple of different kinds of data or different types of monitoring you would want to do. So you would want to do distribution monitoring and drift monitoring. You also just want to do basic data quality checks. Hey, does this data look like I expect it to? Like I expect, right? As there are a bunch of nulls where there shouldn't be. And so we're trying to build things to be as pluggable as possible so that different tools can different modern data quality tools. A great example of this is Great Expectations can plug in really nicely into the Tecton feature store, and we've built a pretty strong primary integration with Great Expectations, but are leaving open that API so that we can work on other integrations with different monitoring providers. And I'll also just mention that there's another really important type of monitoring that's very impactful in operational machine learning, and it's this concept of training serving skew, which is really around validating that the data that's being used in your production environment for predictions looks like the data that your model was trained on. That data can shift or be different for a variety of different reasons. Maybe some online pipeline is broken or things were not implemented correctly, but it could also just come down to something like the world has changed, and the distribution of data going into your model is now different. But you want to know about those. It's not always immediately obvious exactly what to do, but often it involves retraining. You want to be alerted about that, and that's a primary thing that we're looking out for. And we think like the feature store is a natural place to apply that monitoring and give those alerts.
And is monitoring something that will be covered in the workshop on Thursday for folks that want to get a concrete sense for how this all works?
We will talk about the monitoring integrations. I don't think we are showing off like a first class integration at that time, though.
Okay. Can you talk a little bit about how the feature store scales with the number of data sources? What is the scaling? How should folks think about scaling feature store scalability? Is it with the number of data sources, the number of features, the number of models?
The core feature store architecture is meant to, we developed this at Uber where we were doing, millions of predictions a second from feature vectors served from the feature store. There's not really like an inherent limitation in terms of like number of data sources, features that can be managed, and even types of features or cardinality of features that can be served. It's all pretty horizontally scalable distributed system. So we haven't really had a customer that's run into any of that type of scaling. However, there are customers who are working with really big data, and so the feature store is not something that's going to solve it's not a magic solution to solving gigantic data problems that were not solvable by other systems. So the feature store will coordinate existing data workflows, but it's not going to be a fundamentally new way to process data.
What are the implications of that from an organizational perspective? Do you want a single centralized feature store so that everyone can find everything, or do you want to use feature stores like namespaces to encapsulate the data that is accessible or relevant to a particular team?
Yeah, good question. So it's different organizations do it differently, and it's very important. It really comes down to data security. And so different organizations don't want, data to be shared across organizations, or they sometimes don't even want metadata to be shared across organizations. But then we talk to different companies who just want one central catalog for all of their features. So there's not one completely right way to do it. It's more about providing the framework so that the organization can apply this to their own sets of requirements and their own infrastructure, and be able to use it as a tool to operationalize and share features the way that works properly for their company.
Right. Last question. How do you maintain context across aggregations of features, for example, to create the vector of data that's being pushed into the input of a model, especially when you have differences in cardinality?
I'm not totally sure what the term context refers to in this case. But when we talk about aggregations, there's often one kind of feature that's very common in a feature store is like a rolling time window. So you might care about how many times did this customer click on this ad, or did any customer click on an ad in the past 30 days or 1 hour or something like that. And so the feature store is a place where is a system that can maintain some of this state for these aggregations to efficiently incrementally compute this stuff. And that's kind of one of the special performance optimizations we've built into the Tekton feature store. So if anyone's interested in that, just hit me up, tekton.ai, and we'd be happy to hop on a call and show you all about that.
Awesome. Of course, you can find Mike here on the Brittle platform. You can connect with Tecton at their booth, and you can join for the workshop on Thursday and go into a ton of hands-on detail of in terms of how it all works. Thanks so much for joining us, Mike.
Thanks a lot, Sam. Thanks everybody for watching.